All right, so we're going to take the derivative of x cubed plus 2x. And we don't know the power rule, any of those yet. We got to use limits. So in the last video, I showed one limit definition of the derivative. Here I'm going to show the other one, which I think is probably the better one. So let's review. What was the other one? The other one, so what was the idea? I'm going to try to say it in words. So the other one, we were taking 2 points. We were taking two x values. The one x value was x. The other x value was a. And so we were doing f of x minus f of a over x minus a. So see, that's the slope between the 2 points of x equals x and x equals a. And what we did was we wanted to see as that x value got closer to a, as that x value gets closer to a. So that's not the idea that I usually think about. The idea that I usually think about is instead of thinking about it as two different points, you can see what's our diagram. So if we had, this is our point x and this is our point a, and we're thinking about making them closer together. We're thinking about turning x into a. But the other way to do it is really, it's like the same idea, but it's just so slightly different. It's like we have this x here, and then we have this other point, but instead of thinking them as the points, we think about the distance between them. So in that case, then this x value is x plus whatever distance is between them. So x plus h. And so now it's like we do the exact same thing, but thinking about it as these 2 points. So instead of like f of x and f of a, we're going to have f of x plus h minus f of x over x plus h minus x. And we're going to see here what happens as h. What happens as the 2 points get closer to 0, what happens is that distance between them gets closer to 0. So there we go. That's our other thing. We just can clean it up a little bit. Notice that these x's cancel out. And so that's your good definition of the derivative. And I prefer to use that one. So that's what we're going to do. So let's just straight up use this as a formula and plug in this equation for it. So f of x plus h. So what does that mean? Plug in x plus h for x. So we're going to have x plus h cubed plus 2 x plus h. And then minus f of x. So minus f of x, x cubed plus 2x. And then all of that over h. And again, we're trying to see what happens as the limit as h approaches 0. All right, beautiful stuff. So now we just got to do the algebra. That's all there is to it. This is why we just have to be really good at algebra for calc. So what is x plus h cubed? Well, you should honestly just be able to do it because it's Pascal's triangle, but x cubed plus 3x squared h plus 3xh squared plus h cubed. And then we distribute the 2. So plus 2x plus 2h minus x cubed minus 2x. Distribute the negative. And all of that over h. And of course, the limit as h approaches 0. And so the idea with these limits is everything without an h in it is going to cancel. So we can even just specifically look for that, like this negative x cubed with this positive x cubed, and this negative 2x with this positive 2x. Because now the idea is, look how everything has an h in it now. So now, since we're dividing by h, that h will cancel out. Because we couldn't plug in h equals 0 before because we were dividing by h. But now that we cancel out all these h's, it's no problem. So what are we left with? We're left with 3x squared plus 3xh plus h squared plus 2. So we don't even have a fraction anymore. And remember what we were doing? We were doing the limit as h approaches 0. And now there's no problem. Now we can just plug in h equals 0. So what do we get when we do that? The 3x squared just stays the 3x squared. The next one turns to 0 because you're multiplying by h. H squared is also 0. And so you're just left with the plus 2. And that should be the derivative of this function. If you know the power rule, you can check your answer real quick. Does that make sense? And if you know the power rule, you will see that it does.